The following properties follow directly from the definition of the log function with base a. So properties 1 and 2 are pretty straightforward. Log base a of 1 will always be 0 because a to the 0 power is 1. Log base a of a will always be 1 because a to the first power is a. Now, the inverse property, though, is something that should feel new and different. So the idea is, if you take log base a of a to the x, and these inverse properties, these inverse functions cancel out. Well, why are they inverses? Let's go into that a little deeper. So remember, if we're given the function f of x equals a to the x, and we want to find its inverse, remember, the first step we need to do is switch x and y. X equals a to the y. And then if we want to solve for y, y is our exponent. So we know that y equals log base a of x. So that tells us that f inverse of x is log base a of x. So what's happening over here is you're plugging this function into its inverse. And when you take a function, its inverse, and you plug it into one another, remember that always leaves x. So log base a of a will cancel out and leave x. The same is true of a to the log base a. They should cancel out and leave x. And then number 4 is pretty straightforward. If you have a log equal to a log, all right, you can basically ignore those logs and know that what's inside of them is equal. So let's take that to simplify a, b, and c. So I have log base 9 of 9. Well, I know that this is going to equal 1 because 9 to the first power equals 9. Now, part B is using that inverse property where 20 to the log base 20 is going to cancel out and just leave an answer of 3. And remember, if our answer is 1, we know that that logarithm equals 0 because square root 3 to the 0 power is 1. So these properties will be used for simplifying, but we'll also use them later on in this unit when we're solving exponential and logarithmic equations.